So hi there, hello everybody. Welcome to Deutsche Telekom and welcome to Mobile World Congress 2019. I'm Helena, happy to be with you. So, no surprise, 5G is a big hype, right? So everybody's talking about it, everybody's expecting big things of the introduction of the 5G communication networks. But once they're introduced, what do we do then? No, will I be, if I'm surrounded by autonomous cars and connected things, talking robots, communicating bits of code, where will be my place as a human being? So, quite a lot of questions, and here comes the man with at least a few answers. Frank Fitzek is Professor for Communication Networks and Coordinator of the 5G Lab at DT. And we are eager to find out more. So, welcome, Frank.
So, thank you very much. It's a pleasure to be here today at the booth and tell you a little bit about 5G and what will come with the technology of 5G, what we can build. And as you heard in the introduction, it's very important to understand what we humans play in the role of 5G. And therefore, I brought mainly two topics. One is the tactile internet, which I will explain, and then also showing why we need 5G campus for such technology. At this place, I would also like to thank Deutsche Telekom for their support, because the research topic tactile internet was created together with Deutsche Telekom. And now we have a center of excellence in TU Dresden for tactile internet with human in the loop, so thank you for that. With this picture, take your seats, relax, and maybe you will hear about what 5G can do for all of us. So when we talk about tactile internet, there's the word internet, and the internet did a wonderful job in democratizing information for everybody, independent of time or location. So if you remember how it was to check information some years ago and how it's now, it's a wonderful world. The tactile internet is going a little bit further than that. It tries to democratizing skills and expertise. So if you know an expert that is good in something, why not taking not only information but his own skills and exchange this globally? In this case, democratizing skills to promote equity among people of different genders, different religions, different ages, cultural backgrounds, or also physical limitations. I think that is the motivation that we have in research, and we would like to build such a system. And if we could build such a system, that would tremendously change the way how we learn when we are young or when we are old. It will change the world, how we will work, our work situation, as well how our medical situation, our medical care will be in from 5 years from now. So I will give you one example. I told you about democratizing skills. If you have a skill, if you have a gift, and you would like to give this gift to a machine, like this industry robot, what are the different ways to really convey skills today? The easiest way is you get just one of these Xbox controllers and you steer the robot. In this case, it's very important to understand that it's not easy to do that, not self-explanatory, and you have to learn a little bit. And really, your skills, what you're good at, it's very hard to convert this into the robot. We have done something about this by making the controller a little bit better. And we have showcased this already 2 years at this booth. And if you remember, there was this robot, Mr. T. And here you see Tim Höttges, who is steering the robot in a one-to-one fashion just by having sensors in jackets in the headset as well in the hands, which was only a reason for making it quick. And now, whenever Tim Höttges was moving, also the robot moved in the same way. So that seems to be a much better controller for such a robot. But this is not everything, because such a system would then would not scale, because you need as many experts as you have requests for a skill. So in order to make it scalable, what we need is to, and this is the way how we do it today in industry, we take the expert that talks to the computer science guy who is then performing source code in order to get this skill on the machine. But this has also some disadvantages. The good thing is it scales. The disadvantage is it will cost you a lot of time. We are talking here about months to get such a skill on a robot. It will cost you also a lot of money. And on top of that, what is also important, and we don't have as many computer science people that are good in programming robots as there will be robots in the future. So how can we break up this skill? And then we come back to the jacket that Tim was wearing, where we have sensors now all over our jackets and trousers, and every movement is directly transported to the robot. So this is the first step as you have seen it. But what happens now is that we are using artificial intelligence to get our source code automatically from that. So the expert will train the robot 2 or 3 times until the AI will understand what is really the job and how we can do it. That sounds fantastic. Can we do it? With this question, 2 years ago, we wrote the proposal to the DFG, which is the German research fund, to say we would like to have 50 million to do research on this topic. At the same time, we also started a small startup in Dresden called Wandelbots, and they tried to see what is already now possible with such an idea. And what you see here is the CEO of Volkswagen with a white jacket with sensors. And what he's doing, he's just taking a loudspeaker and pressing it into the door in the production process. He did this 2-3 times, and afterwards the KUKA robot understood the job to do and tried to do that. So that is fantastic if you would like to reprogram your robots. And if you understand the promise of Industry 4.0, which are smaller lot sizes or lot sizes down to 1, we need robots to be reprogrammable, and this also in short time. Wandelbots made a tremendous journey since 2 years now. I think there will be up to 100 people end of the year working in the company, and this is already functional right now. And one other thing I would like to show you is a small school kid of 14 years that came to Wandelbots and asked whether she can do something with the robots. And what you see here is the kid with the sensors. You can see them, the orange points. These are sensors. And with the sensors, she is teaching skills to the robot in order to stack something, to do some jobs. And in 1 week of her period that she was with us, she trained over 4,000 skills to a robot. So this is quite fascinating how fast and how many skills you can teach. So you could see that something of the idea is working. So what is left? And what we would like to do is to make this idea to work it on a global scale. So instead of the all example you saw, the expert and the robot are staying in the same room or very close together. And now we would like to get the skills transported globally to any place in the world. There's one requirement what we would need, and this is the multimodal feedback. So you have, if you go around here on the booth, what you see is a lot of people that are working on AR, VR in order to get a visual feedback. I think that works. The quality is great. There's something, the problem with the latency. A latency in our order, what we will need. But it's not only video and audio what we need a haptic and tactile feedback. And this new kind of feedback, that is really challenging. So where is the research then? So first of all, you have 3 different senses. As I said, audio, video, and haptic. And if you understand the latency requirements, then you know that video, some people are sensible up to 15 milliseconds. So if the video is delayed by only 15 milliseconds, they don't feel this as the real experience. Audio is even more challenging with 3 milliseconds. So if you take a guitar and you hammer on one of the strings, if this signal does not come in 3 milliseconds to your ear, you will not see that this is your own instrument. And then the most challenging is tactile, which is only 1 millisecond. And when you go around and you talk about low latency, reliable communication in 5G, you often heard the term 1 millisecond. 1 millisecond is something that comes from machines, like energy grids, from robots, but also the human being has the requirement of 1 millisecond. So what you see here is the impact on latency on humans. There's this lady who has some goggles and a camera, and we just delay the experience of the real world by a latency twice as much as LTE. So if you would like to operate in a virtual world today, you cannot do this with the fourth generation. That's the requirement of 5G. A lot of things that 5G was promising was multimedia. Even IoT can be done on an advanced Pro of 4G. But low latency is the killer app in different forms of 5G, what you can see here. So 1 millisecond, what's the problem with the 1 millisecond? It's not over-the-air communication. You can do that. The problem is, the problem is speed of light. If we talk 1 millisecond, then speed of light is too slow. Why? Because our idea is to promote skills worldwide. But speed of light means that the light travels only 300 kilometers in 1 millisecond. As we have to go back and forward for our haptic feedback, this means that in the best, you have something around 100 kilometers. The situation is even worse because you will spend your 1 millisecond on different things. You have a sensor and an actuator. And the latency between those is you will lose a little bit on the embedded devices, like 10% on both ends. On the wireless link, 10% on both ends. And then you need also, and this is even challenging part, the softwareization will eat up to 35% of the latency, which leaves you up only to 25 kilometers between a mobile edge and the sensor actuator pair. And this would limit us because the skills would not go globally. How can we crack this problem? So, as we cannot directly talk with a robot from Barcelona to Japan or New York, what we plan for is to teach a virtual twin. So as a human, I will only have a virtual twin of the machine next to me, so virtually a meter from me, and then I would train the machine, and the machine would then interact in the real world with a digital twin of the human. And there are two questions. First of all, where do we place these models of machines and humans? This is a very nice idea for a mobile edge cloud application. The other thing is, it's easy to model a machine, but it's very complicated to model humans because we are all different. If we talk about latency, some of you are more prone to latency than others. It depends also on the age. If you ever wonder why you're losing on FIFA against your kids, the reason is they are just better trained to latency. And the older you get, the harder it will be to work with latency. So our network needs to understand human beings and their need for latency. Once we have done that, so transporting skills from a human to the machine, it would be great to get these skills back to the humans. So now we are switching positions. The skills are in the network. In a kind of a machine, could be, but it could be also virtually in the network. And we would like to train human beings. And then you see on the left the human being again with a white suit. And all these sensors, hundreds of sensors, recording my movement. There's something else what we need. Not only sensors, we need actuators. And in case you don't want to have a fixed exoskeleton, we also need flexible electronics for that. I just brought you something here. This thin layer is printed, it's flexible, and these are electronics. And this will go into our clothing. You will not even see it. So every connection that nowadays we really do with PCBs and cables will be just engraved into our in our clothes. So the other thing that we have to engrave there are actuators. It's some kind of a soft exoskeleton so that I can move my jacket. That's quite new, but we already made some tests with a glove where you really can show the people how to move the hands. Very good for playing the piano. But if the challenge is to teach people playing the piano, we are not yet fast enough. So there's a lot of research that has to be done on the soft exoskeleton in the glove to be faster, because teaching must be also come with the speed there. The other thing what we have to learn is how will humans learn? I give you one example. If you see now younger kids with a bicycle, they are wonderful in bicycling. In early days, in my youth, the people struggled to bicycle. Why? Because there are two problems. One is the balance, and one is the pedaling. And nowadays, the kids have the bicycles without pedaling. They're just running with it. So they learn first the balancing, and then the pedaling. That is, you separate the problem, the learning is easier. These kinds of tricks we have to understand to train humans, and this will lead to a totally different world of learning. Another example, for example, could be that you, when you go on rehab because your shoulder was dislocated, you get a jacket, and your doctor has a jacket, but you don't have to drive there. The doctor will call you over video chat, and then the doctor will show a movement. The jacket will automatically make the movement until maybe it hurts, and then the doctor will say, you do this now 10 times. And you call the doctor 8 times a day. This will be a good process, and there's a lot of success in the rehabilitation in this case. Other use cases, for example, are sports that we are doing in rowing. Dancing is something that we actually showcase, or even climbing, helping the people to find the right route in the mountains, or making it more challenging in limiting your degrees of freedom in climbing. Last but not least, if you have both direction, it would be great to understand how humans and machine will end up in co-working. So how can they really interact with each other? Nowadays, robots are in cages, and nobody would like to enter these areas. But in the future, because of the promise of Industry 4.0, we have to interact with humans. And here, the human is the part that brings up the innovation part. And the machine will be the part where the repetitive work will be done. And this is a new way of working. It's not stupid work where you always have to do same and same again. The worker, the human being, has to bring up innovation. So you can imagine what this means for our kids in schools, what they should learn. They should not learn knowledge. They should learn how they can really make innovation, which is a new thing, I guess. So when we have that, then I think we have different impacts. We will have impact on research. I showed you the flexible electronics, the way how we understand humans, how we will have also the training and the teaching of human beings. There's a lot of questions that we will undergo in our research project. We have 7 years' time, and we are looking forward to do that. The second part, the business will change. So once you can really make small lot sizes and you can reprogram the robot, it will give you a totally new way of products that you can have. And of course, I already mentioned it a little bit, society will highly benefit from such a system. Now, the only thing, what has 5G to do with that? Of course, the communication between human and machines will be done via 5G. Things like Wi-Fi, for example, will not work because listen before talk has nothing to do with latency. That's just best effort, and you cannot really guarantee low latency. With 5G, we have the first technology that goes to areas where we have not been before, where we get this kind of 1 millisecond latency. So then the question is, what is so different in 5G besides the fact of latency? It's not only the fact that 5G has a better air interface, it will also impact the wired world more than we even know. Interestingly, if you talk to the internet group and said, what is your generation? In mobile communication, we have the 5th generation. What is your generation? They don't even know what a generation is because they just have software. They can update their stuff on a daily basis, where we in the mobile communication area, we have to wait every 10 years to get a new generation. But as we are now bringing these two things together, 5G, hardware and software, we also will see that the update rate will be the same as now in the internet. There are some presidents out there that ask for 6G or even 7G, I don't know. But when we really come with the softwareization of such networks, it's pretty clear that we don't talk about generations from that day on. So what is this 5G? I always explain this to our students and also to other people that would like to know it by the 5G atom. I think you have heard about IMT 2020, where they have the triangle telling you about multimedia and massive IoT. That will be also attacked by 4G because they can do it. The other corner of low latency, that's the interesting part. And if you have an atom, you always have the core, and we see in the core there are the use cases. So far the use cases are of course autonomous driving, robotics, construction, agriculture, e-learning, a lot of things, but now also our tactile internet. And there are some technical requirements. Latency is one of them. High data rate is another one. Security and also resilience. If you want to steer a car over the highway with 250 km/h, it should be freaking reliable. The problem is not to have networks that fulfill these requirements in a single term. But if you want a combined way of 1 millisecond and 10 gigabit, there is a physical limitation. From the information point of view, you cannot bring this up in this same time. Now, in order to deal with this challenge, you have to come up with new concepts. Of course, we will see a new air interface. We will also change the cellular architecture, which is not only cellular anymore, it's a hybrid meshed type. So there are devices talking to each other, so devices to devices. And there will be also a different way. Nowadays in the internet we have a single pass communication, but we will see in the internet multi-pass communication and on the air interface multi-connectivity way in order to get this resilience. And then there are two terms I think you have heard here in Barcelona many times, and maybe also the years before, a little bit less loud than today, but it's about the mobile edge cloud and the network slicing. And also in the tactile internet that we discussed, we will need it. I'll show you it a little bit. These are core elements. And how do we really get these things to life? Of course, the next belt and tier with electrons is called the softwareization one. We will have SDR, NFV, SDN, ICN, all these terms. This is open source where we can build up these new concepts with. But there are some requirements, as I said. You only have 0.35 milliseconds in order to get your mobile edge cloud up and running. And this is the maximum latency it can do. This is challenging today. And what we are doing from the university and research side is the outer tier. We think about how can we make this open source unique that you have a new product